Good morning to all. Today I'm going to give the presentation that is demo on the relational database management system. In that, the topic normalization. Myself, Kirti P. I'm going to give the presentation on the normalization. So before going to know about the normalization, why actually the normalization is needed? So the main goal of designing the database is to achieve the minimum redundancy, because once we design a database, the redundancy should be reduced, and whatever the information that we are going to store in the database, it should be preserved. These are the two main implicit goals in order to design a good database. So this should be considered. And the next is some criteria for designing a good database, and how to overcome the designing of the bad database. Next, the process of normalization using the functional dependencies. So if you are applying the normalization process, how to use the functional dependencies in order to design a good database. So these are the 4 informal guidelines or measures that should be considered while designing the good database. So main important task in order to design a good database is applying the normalization process. So why we actually apply the normalization process to the database? Because once we design a database, we should make sure that the semantics of the attributes is clear in the schema. Schema in the sense that is a table without any data in that relation or a table. So making sure that the semantics of the attributes is clear in the schema, in the sense, whatever the attributes we are going to specify in a schema, it should be meaningful. Suppose if I say employee is a schema or a table or a relation, whatever the attributes I am going to specify, it should give some meaningful information or meaningful name for that particular attribute. Employee name, address, salary. This is the semantics of the given attribute. So we should make sure that the semantics of the attribute should be correct for that particular table or a relation or a schema. The next one is reducing the redundant information in tuples. So if we are providing the same information again and again, it causes inconsistency and more data will be present in the database, which causes the data redundancy. So the main important task of applying the normalization is to reduce the redundancy. So this is the main drawback of designing a good database. So we have to consider, we have to reduce the redundant data that is present in the database. And next is reducing the null values in the tuples. Reducing the null values. Suppose if the information is not known, if it is unknown, in that cases we will be representing the value of that attribute as null. So that should be reduced as possible. We should reduce the null values present in the database. The final thing is disallowing the possibility of generating the spurious tuples. Spurious tuples means unwanted information. Suppose if I join any 2 tables, it should not generate some unmeaningful row or unmeaningful record. So that gives us spurious tuples. If I join employee table to the department table, so employee table contains employee name, address, salary, and department table contains department name, department number, department location. If I join 2 tables, it should say that employee name, employee John works for some particular department, name, number, location. That gives some meaningful tuple, meaningful row. Whereas if I join the 2 tables in such a way that one particular department number, like 5 with the department CS or EC having salary so and so, that row doesn't give any sense. So that type of tuples. So the rows which we got, which it is obtained by joining 2 tables, which is not giving any meaningful information, then we will consider that as a spurious tuple. So main issue, important guideline in order to design a good database is we have to disallow the possibility of generating the spurious tuples. So these are the main 4 measures that should be considered while designing a good database. So in order to achieve the normalization, we have to consider these 4 drawbacks in order to design a database. So first is making sure of the semantics, that is meaning of each and every attribute what we are going to give it for a table. And next is reducing the redundancy data present in the table. Next is reducing the null values, and next is the disallowing the possibilities of generating the spurious tuples. So one of the main important concept in order to achieve the normalization is functional dependency. So what is a functional dependency means? Functional dependency is denoted by X determines Y between any two sets of attributes X and Y that are subsets of R, specifying a constraint on the possible tuples that can form a relation state smaller of capital R. So this is actually a definition. In general, let me explain what is a functional dependency. A functional dependency can be determined as X determines Y. So X determines Y means, suppose consider R is a relation schema. Consider R, here we will consider R as an employee, is a table, which is a relation. In employee table, suppose if we consider in employee, we have employee name. These are the attributes, SSN, or we will consider it as EID, and employee address, salary. These are the attributes that are present in the employee table. So now here we will consider R as a relation schema. So capital R is a relation schema. For example, we have considered R as a employee table or employee relation. So this is a relation schema, that is employee. In this relation schema, what we are telling is X determines Y is a functional dependency. That is, X functionally determines Y and Y is functionally determined by X. So what does this mean is X is a set of attributes. X is a set of attributes which are subset of the relation schema capital R. So here I am considering that as EID. Here I am considering the X as EID. We have to choose an attribute in such a way that it determines all the other attributes. Next, Y will be the set of attributes which are determined by the X, that is, which is determined by EID. Those are e-name, e-address, salary. So this says X is functionally determines Y. So if we consider this example, what is X? That is EID. EID determines e-name. EID determines e-address. EID determines salary. So in this way, it will determine whatever the attributes that are present in a given relation schema will be determined by some main attribute, that is EID. So we should identify which attribute determines all the other attributes. Suppose consider e-name. If you consider employee table, in employee table, we have e-name, EID, e-address, salary. So if we have these attributes in our employee table, suppose consider John. John, his EID is E11, his address is Bangalore, and salary 30,000. Next, if we consider another employee, Smith, his ID is E12, belongs to Bangalore, and salary is 25,000. So what does this say? We should consider an attribute in such a way that it should determine all the other attributes. Can employee name determine salary? The employee name can determine salary, but if I have the same employee name John, so if there are two employees with same name John, then it can't determine which employee salary is 30,000. So it may be we can use it for identify all the other attributes, but it is not unique. So identify an attribute in such a way that it should be unique, and with that we can able to identify all the other attributes. Next, address. With address, we can't able to identify either name or salary. In the same way, with salary, we can't able to identify either name or address, because the same salary can have to any employees. So identify an attribute in such a way that it should determine all the other attributes. So that is employee ID. So X becomes EID. So identify an attribute which is a subset of the given relation, that is employee. So that is a subset, means the element that is present in that set, that is EID. So X is a set of attributes which contains set of elements that is present in that set, that is subset of the given set. Similarly, choose the elements Y in such a way that those are subsets of the given set, that is relation capital R. So we have chosen X and Y. X determines Y, that is X is X here EID determining ename, and ename is determined by EID. Hence, we will call it as functional dependency, that is X functionally determines Y. So EID functionally determines ename. So that is called the definition of functional dependency. A functional dependency over a relation schema capital R. Here we have taken that relation schema as employee. Over a relation schema capital R, where X determines Y holds when, what is that? X functionally determines Y. How to choose X in such a way that it should determine all the attributes in the given relation schema. Y is the other attributes which are determined by the attribute that is present in X. Suppose, according to the definition, what it is T1 of X. T1 of X equals to T2 of X. If there is consider any two tuples T1 and T2 in a given relation schema, where T1 and T2 are two tuples. I have considered these two tuples, that is rows. Consider any two tuples T1 and T2 in such a way that if T1 of X equals to T2 of X, then T1 of Y equals to T2 of Y. So what does this say is, if you choose any tuple, any two tuples in that T1 of X equals to T2 of X. What is X? I have taken X as EID. So T1 of X equals to T2 of X means E11, this tuple and this tuple. T1 of X is E11, T2 of X is E12. If these two are equal, if E11 equals to E12, then definitely T1 of Y equals to T2 of Y. Means Y is, suppose if you consider Y as E name, that is this as X and this as Y, EID as X and ename as Y. Then if E11 equals to E12, then ename values. What is that? John equals to Smith. What does it say? Means if you take any two tuples in a given relation schema, in a given relation, then what happens? T1 of X, no two tuples should be same. If those two tuples are same, then the functional dependency does not hold. So if these two are same, then these two should not be, these two should be same. In the, what does it say means no two tuples. If you take any two tuples in such a way that T1 of, that is EID equals T is equals to T2 of ID means, then definitely this should be different. That is John and Smith. So no two tuples should be same. All the tuples what you're going to take should be unique. So EID determines ename means E11 determines John, E12 determines Smith. They, if you take any two tuples, then exactly it should be unique. No two tuples should be same. In a contradiction, it is explaining that if T1 of X equals to T2 of X, then T1 of Y equals to T2 of Y. So if you take any two tuples present in a given relation, then those two should not be same. It should be unique. So that is the definition of the given relation schema. So let me show you the definition once again. So functional dependency denoted by X determines Y between two sets of attributes. So I have told X as EID and Y as ename, address, salary, that are subsets of R. So these are all the elements that are present in a relation employee R. Specifies a constraint. What constraint? On the, that is on the possible tuples that can be formed on a relation state smaller. What does it mean by relation state smaller? Means once the relation schema is populated by data, then we will call that state of a relation as relation state. Means a table contains the data. We will call that as relation state represented by small r of capital R. Capital R is a relation schema, what we are talking. The constraint is that, then what is the constraint for any two tuples T1 and T2 in small r, that is that relation which contains the data. In that, it will have T1 of x equals to T2 of x, then they must have T1 of y equals to T2 of y. So what does it say? No, if you take any two tuples that is present in a relation state, those two states should be unique. It should not be same. So that is called as a functional dependency. Yeah. Just a minute. Yeah, that is called a functional dependency. Next, now we are moving on to the normalization of relations. So why normalization is required? The normalization of data can be considered as a process of analyzing the given relation schemas based on their functional dependencies and primary keys. So whatever the normalization we are going to apply on the database, that will be considered based on the functional dependencies and the primary keys. In order to achieve these two, we have to consider these two properties. The first one is we have to minimize the redundancy, and second one is we have to minimize the insertion, deletion, and updation anomalies. So in order to design a good database, so whatever the database we have designed is that it is giving a good production, good design, then we have to apply the normalization. So why we are going to apply the normalization? Because we have designed the database, but it contains some redundant data, but it also has some insertion, deletion, and updation anomalies. So in order to overcome these two, normalization will be applied to the database. So minimizing redundancy is called redundancy, means existing of the same data in more than one place, causing redundancy. So this redundancy causes inconsistency of data. So we have to reduce it. Otherwise, whatever the queries what we are going to apply on the database, it may not give some valuable input, valuable output for our given query. In the same way, we have to minimize this insertion, deletion, and updation anomalies. So before going to know about what is this normalization, we should understand how to reduce these redundancies. So the first one is minimizing the first one is minimizing the insertion, deletion, and updation anomalies. The first is reducing the redundancy, and the next one is minimizing the updation anomalies. Reducing the redundancies will be done by using the different normal forms what we are going to apply. So we understood what is a redundancy. That will be reduced by you applying the normalization techniques. The next one is minimizing the updation anomalies. In updation anomalies, we have three types of anomalies. One is insertion anomalies, deletion anomalies, and update anomalies. So first we will consider about the insertion anomaly. In this, what is an insertion anomaly? Yeah. So in the insertion anomaly, consider I have taken employee department relation. So in the employee department relation, so why I have taken employee and department relation? Because the main important thing of designing a good database is that first step is to reducing the wastage of storage space in the database. So the first step to design a good database is we have to reduce the storage space. So if I create employee table, department table, if I'm going to create one big database, it contains n number of tables. We have to reduce the space that has been taken by the tables. In order to overcome that, we have joined the tables, employee and department table, together into a single table. By using a natural join, we have created a table called employee department. So why we have created this table? In order to reduce the wastage of the storage space, a single table will be created instead of creating more tables. Instead of creating 15, 20 tables, we can join the related tables into a single table so that the space can be reduced. So now we have considered. So once we have considered the employee and department table as a single table, there comes the different types of anomalies. What are those? Insertion, deletion, and updation anomalies. So now first consider the insertion anomaly. In the insertion anomaly, the employee department table. In this table, we have the attributes as employee name, EID, e-address, salary, then department number, department name, and then department location. So these are the attributes that are present in the given table. Once we join employee to the department table, then we got these are the attributes that are present in this table. So the first one, what we are going to take is employee name, that is John. John's employee ID is E11. Next, e-address. Address of the employee, that is Bangalore. And next, salary of the employee, 30,000. The department name, let it be D1. And department name CS, department location, Bangalore. So next, I will take the next employee name, that is Smith, that is E12, belongs to Bangalore, 40,000, belongs to department D1, CS department, Bangalore. Yeah. So inserting the employees to that particular department. So once we know who are the employees for the department, then there will be no insertion anomaly. Then what is the problem when occurs the insertion anomaly is when there is a department, newly created department called D5. So in D5, we have a EC department, Bangalore. So newly created department, if there are no employees currently, EC department is the new department in which there are no employees in that department. In that case, insertion anomaly occurs because after applying natural join to this table, employee to the department table, employee ID becomes the primary key. So in that case, suppose if we have a department considered D5 in which it doesn't contain any employees, so newly introduced department which doesn't have any employees, but we have created an employee department table which contains all these attributes. In this, EID will be considered as a primary key of the employee to department table. So if it is a primary key, then it should not be unique and it should not be null. So if there are no employees present in the given department D5, then we will write this as null, because null in the sense there are no employees in the given department, that is D5. So here we will write it as null for e-name, and we can write null for address, and we can write null for salary. But we can't write the null value for the EID, because EID is the primary key of the given table. Then EID can't be null. Hence, this causes the insertion anomaly. Insertion anomaly means the main use of joining the two tables is to overcome the shortage of the, that is in order to reduce the wastage of the storage space. We have joined the two tables by applying natural join. When we consider this type of table, that is employee to department table, which contains EID as the primary key in this table, we can insert n number of employees who are belong to one particular department. Suppose if so, the problem occurs in the insertion anomaly. That is, the problem occurs is when we introduce a new department, that is D5, that is EC department, in which currently there are no employees in that department. Then if I want to insert the details of the department EC, then it will not allow us to enter the null values for this attributes. It can enter null values for all the attributes, but it will not allow the null value for employee ID, which is the primary. So this causes the insertion anomaly. The next one is deletion anomaly. So deletion anomaly, it is same as the considering the same relation, that is employee department table. Consider deletion anomaly. Yeah, in deletion anomalies, We will consider the same table, that is employee to department table. So in this table, we have employee name, employee address, just employee ID, employee address, salary, department number, department name, department location. So these are the attributes that are present in this table, right? Suppose if I have to delete one particular name. Suppose if we have employee name John, whose employee ID is E11, address Bangalore, salary 20,000, department D1, department name CS, location Bangalore. And next employee Smith, E12, Bangalore, 30,000, belongs to D1, CS, Bangalore. So there are two employees in CS department, just for an example. Next, we have another employee called Sam, E13, Bangalore, salary 34,000, belongs to D2, EC department, Bangalore. Next, Sam, E14, Bangalore, 40,000, department D2, belongs to EC department, Bangalore. Next, we have another employee called Joe, E15, Bangalore, 50,000, D3, mechanical, Bangalore. So if I want to delete one particular, I don't want this employee Smith, so I want to delete it. If I delete this particular employee details, still the department D1 exists. So there is no problem if I delete the employee. If there are more number of employees in a department, if I delete any one of the employee in that, there is no problem. Still the information of the department will be present. But if there is only one employee, see, if Joe is the one and only employee who is present in the department D3, then in that case, if I delete the employee Joe, then the details of employee, along with the details of employee, the details of the department mechanical will also be deleted. Now, there is no details of the department mechanical. Along with employee details, the department details is also got deleted. So this causes the deletion anomaly. Deletion anomaly means in the department, if there are more number of employees, if I delete any one particular employee, then there is no problem with the deletion anomaly. But in any particular department, if there is only one element, if I'm going to delete that element, he is the last employee present in that department, then it along with that employee details, the department details will also be deleted. So the information regarding the department is lost along with that employee. So this causes the deletion anomaly. The next one is updation anomaly or update anomaly. Update anomaly in the sense, suppose consider we have another attribute called department manager. We will consider it as manager EID. Manager EID is the EID of the manager. So that is already the employee ID of any one particular employee that will be taken here. Suppose the manager of CS department is E12. The manager of EC department is E15. And the manager of EC department, so it is same, that is E15. Suppose if we have the details like this, because what is this says is, John is an employee, his ID is E11, belongs to Bangalore, salary 20,000, belongs to department D1, that is CS Bangalore, and his manager is E12. So E12 will be the manager of the department CS. E15 is the manager of department CS. So if I update the HOD or the manager of the CS department from E1 to E6, there is no problem because there is only one row for the CS department. There will be no problem with updation. I have changed that to E16. If there are more rows for that particular department, now I want to change the manager of department EC, or we will consider it as instead of manager, we will take it as HOD. So if we change the HOD of the EC department from E15 to E17, then this row says I have changed the HOD of this row as E17. Now what it says for the EC department, the HOD is E17. But another row says the HOD of EC department is E15. So if you are updating one particular row, you have to update all the other rows belong to that particular department. Otherwise, it causes the inconsistency. So what does it say? For SAM, the HOD is E17. For SAN, the HOD is E15, which causing the inconsistency of data. So this causes the updation anomaly. Means if you are updating any one particular row, it should update all the other rows. So this causing the updation anomaly. So while designing the database, we have to consider the insertion anomaly, deletion anomalies, and updation anomalies. If we overcome these anomalies, then and if you minimize the redundancy, then the database what we have designed is a good database, which is giving the which works in an efficient manner. So first is we have to minimize the redundancy, and next one is to minimize the insertion, deletion, and updation anomalies. In order to achieve this, we have to use the normalization process. So normalization process is based on the functional dependencies and primary keys. So what is a functional dependency? Means always the dependency should hold, means it contains some attribute which determines all the other attributes. So based on the functional dependencies, there are different normal forms that can be considered in order to achieve the normalization. So now we will look on to the normalization process. So this also includes the if you are going to apply normalization, it also includes two more properties. One is non-additive join or lossless join property. Means if we are joining any two tables, or if we are decomposing, means dividing the table into n number of tables, we should remember that there should not be any additional information, or it should not lose any non-additive join or lossless join. It should not have any addition of information into our database, or it should not lose any information. We should consider these two things. And the next one is dependency preservation. So whatever we do, whatever the normalization we apply on the databases, it should always hold the dependencies. That is, functional dependencies should hold in the database. Based on these things, we have to apply the normal forms for the given database. The first one is first normal form. So what is the first normal form? It states that the domain of the attribute. Domain of an attribute means the value of an attribute. Suppose consider ename is an attribute. John becomes the domain of an attribute. Must include only the atomic value. It should be a single value. And that value of any attribute in the tuple must be single value from the domain of that attribute. So what does it say? Means first normal form means a relation scheme, a relation, whatever the table we are going to consider, it is in first normal form, means it should not have a multi-valued attribute. Suppose if we consider the employee table, in employee table, e-name, e-address. Suppose let me take the department table. This gives more attributes. Let me take the department table. In the department table, we have department name, department number, and department location. So department name CS, department number D1, location Bangalore. Next EC, department D2, location Chennai. If this is so, there is no problem. Suppose if I consider the EC department is located at 3 different locations: Chennai, Delhi, Calcutta. So now if you consider a domain of an attribute means, suppose consider this is an attribute, that is D location. Domain of an attribute means the value of an attribute should be single atomic value. If I consider this value, it is a single value. It doesn't have any multi-value attributes. If you consider the second row, the department location, this attribute has multi-valued attributes. It doesn't have a single atomic value. Hence, this is not in normal form. So what does it say? A relation department should be in a first normal form, means it should not have a multi-valued attributes. It should have only a single atomic value. The domain of an attribute means value of an attribute should have only a single value. But this department, this relation is not in first normal form because the domain of an attribute, which attribute delocation is having multi-valued attribute. Hence, it is not in first normal form. How to convert this into first normal form? Decompose the relation into n number of rows. Okay, next we will convert this department relation into n number of rows. That is department name, department number, and department location. So now CS department. In CS department, it doesn't have any multi-valued attributes, so I will write it as it. Next, EC department. EC department, department number D2, Chennai. So we are decomposing the set of elements into single rows. Next, EC D2, Delhi. Next, EC D2, Calcutta. So now, if you consider the domain of an attribute, each attribute, each row, each attribute is having single value. Hence, now this department is in first normal form. So our relation is in first normal form. It should not have a multi-valued attribute, that is in this form. Hence, we can tell that the relation now, the department relation is in first normal form. Next, we will move on to second normal form. Our relation schema is in second normal form, means it should not have any partial dependencies. A relation schema, let me explain about the second normal form. Second normal. A relation schema is in second normal form, means it should not have any partial dependencies. It should contain all full, whatever the dependencies we have, it should be fully functionally dependent. Then that the relation is in second normal form. Then we can say that the relation is in second normal form. Consider employee department table. In employee department table, whatever the attributes I have taken very few attributes just only for the understanding purpose. It may have more attributes. Because of the space constraint and time constraint, I am not taking all the attributes. So in the employee department, let's take e-name, e-ID. Next will be, let me take, instead of taking this department, this relation, consider employee table and project table, then works on table. So these are the tables which have the attributes employee name, EID, e-address, salary. These are the attributes that are present in employee table. Next, consider project table. It contains project name, project number, project location. Next, take the next table that is works on, that is EID, then project number and working hours. So these are the three tables. Instead of considering these three tables, we have applied the natural join to these three tables and converted that into a single table called employee project table. So now the attributes of this table are employee name, EID, project number, project name, working hours. So these are, I have taken only few attributes. These are attributes for employee ID. I have just taken E name. For project number, I have taken P name, and EID, P number together, it gives working. So in this, what is the primary key? Here the primary key is EID. Here the primary key is EID, project number. This together forms the primary key. So now what happens? This EID, what is the functional dependency of this table is? The functional dependency of this table is EID, project number, determines working hours. The next functional dependency is EID determines ename. Next functional dependency is project number determines project name. If we consider these three functional dependencies, these are the functions. What it says, EID and project number is a primary key. It is determining working hours. Okay. Next is the ename. EID project number will not determine ename. What is determining ename? EID is determining ename. Project name, P number is determining project name. So now these are the functional dependencies in the given table. So now in this table, what is this second normal form? First we have to check whether it is a first normal form or not. So all the domain of an attribute has a single atomic value. Hence we will consider this is the first normal form. Now we are going to check whether it is in second normal form or not. So what is second normal form means? It should not have any partial dependencies. Means partial dependency means part of the primary key should not determine any other attribute. So this is the primary key. EID project number is the primary key of the given table. So part of the primary key means EID. If you consider part of the primary key means EID, or part of the primary key means project number. Any one of these should not determine any other attribute. So part of the primary key, EID. Is EID is determining any other attribute? Yes, EID is determining EID. So hence it is not in second normal form because partial dependency exists. What is partial dependency means? Part of the primary key is determining some attribute. So here part of the primary key is determining the attribute. Same way project number is also determining the attribute P name. So hence partial dependency exists. Yeah, partial dependencies exist. So primary key is EID and project number. Part of the primary key is determining any other attribute means partial dependency exists. Hence it is not in second normal form. What is second normal form means? It should not have partial dependencies. It should have a full functional dependency. So no full functional dependency exists because part of the primary key is determining the other attribute. So hence this schema is not in the second normal form. Now we have to convert this into second normal form. This schema, we have to convert this into second normal form. So take out the functional dependency which is causing the problem, which is not, which is having partial dependency. So first take out what is that EID. EID determines ename as one table. Next P number determines P name as one table. Then write the other table as it is. What is that? Ename, EID. Yeah, what EID we have taken. What is rest? That is EID, project number, working hours. Yeah. Now we have decomposed this employee table, employee project table into three tables. What is that? E1, which contains EID and ename. Next one is E2, which contains project number and P name. Next table that is E3, which contains EID, project P number and working hours. So now we have decomposed the employee project table into three tables in order to achieve the second normal form. So what is the second normal form? It should not have any partial dependencies. Now if you consider this relation E1, EID is the primary key. EID determines ename. So part of this primary key, there is no part, only one attribute is present in the this attribute, that is EID, in the primary key. Hence, it is a second normal form. If you consider E2, in this E2, which is primary key, project number. So there is no part of this primary key, only one attribute is present in primary key. Hence, it is in second normal form. Next, if you consider E3, EID and project number is the primary key, and together it is determining working hours. Hence, it is in second normal form. So from this, we can say that E1, E2, E3 are in second normal form. So in the employee project table, we should identify the partial dependency. What is partial dependencies? Part of the primary key, if the part of the primary key is determining any other attribute, hence it is not in second normal form. This is called second normal form. Next, the next one will be the third normal form. Now let us discuss about the third normal. third normal form. So third normal form means it should not have any transitive dependencies. Suppose consider employee table, employee to the department table, employee to the department table, applying natural join, we got this table. In this, the attributes are employee name, EID, let it be only one attribute, employee name, EID, department number, department name, and then department location. So along with this, we have manager ID, that is HOD, EID. Yeah, we have these attributes in this table. Now, what are the functional dependencies of this table? The functional dependencies of this table are, here the primary key is employee ID, is the primary key of this table. So primary key determines, that is EID determines name, EID determines department number, EID determines department name. Yeah, no. EID determines name, department number. That's it. EID will not determine department name. EID can only determine the name of the employee and which department he is working. The department number will be determined. And next, department number determines department name, department number determines department location, department number determines HOD, that is the manager or HOD of that particular department. So here it contains the transitive dependency. What is the transitive dependency means? Employee ID determines department number and department number determines department name, department number, department location. So a relation schema is in third normal form if it doesn't contain this transitive dependency. What is this transitive dependency means? X determines Y and X determines Y and Y determines Z. Then X determines Z. Right? Anyhow, X determines Z. Then Y X determines Y and Y determines Z. If this exists, then transitive dependencies exist. So if transitive dependencies exist, then it is not in third normal form. So if it is not in third normal form, we have to convert that into third normal. So remove those dependencies which is causing the problem. What is those dependencies? That is department number determining department name, department number determining department location, those things. So we have to decompose this table into two tables. One is EID, name, department number as one table. Next will be department number, department name, and department location. So we are dividing this table into two different tables. That is, we will consider it as D1 and the another table is D2. So a relation schema is in third normal form if it doesn't contain the transitive dependencies. If transitive dependencies exist, then you have to decompose the table into two tables in such a way that it should not have any transitive dependency. So now if you take EID determines name, EID determines department number. Again, department number, it is not determining. Next here, this department number determining department name, this department number determining department location. So hence there is no transitive dependency. There is another definition for a transitive dependency. A relation schema is in third normal form means it should be in first normal form, second normal form, and then it should not have any transitive dependency. If transitive dependency exists, then we should consider one condition, that is X determines A. What is this X determines A means? If you consider any transitive dependency exists like this, then you should whether check that either X should be a super key or A should be a prime attribute. If any one of these condition is true, then even though transitive dependency exists, still it is in third normal form. If either of these condition doesn't satisfy, then it is not in third normal form. You have to convert that into third normal form by decomposing it into the n number of tables. So X should be a super or A should be a prime attribute. Prime attribute means one of the Prime attribute means the attribute which is the candidate of any primary key. Then we will call that as the prime attribute. Super key means it is same like a primary key in which no two tuples will be same. If you consider any set of attributes as a super key means no two tuples should be same. Then we will consider that as a super key. So here either X is not a primary key, that is X is not a super key, nor A is a prime attribute. Hence, we can decompose this into two equal parts. So this is called third normal form. In order to achieve the normalization, we are using first normal form, second normal form, and third normal form. And also we have Boyce normal form, fourth normal form, and fifth normal form. So first normal form, this is what I have explained. Second normal form, yeah, we have decomposed that into three relations, and third normal form, decomposing that into two relations. Thank you.